Hey everyone, welcome back again. So this video is all about understanding the clustering aspects in Google Cloud's BigQuery. So basically, we are going to understand clustering step by step, conceptually first, followed by a hands-on demonstration so that you can get a clear picture on what clustering is all about. Right? So before going into the video, let's understand what basically the clustering is in very simple terms or very layman terms. So basically the clustering means that you are organizing the data. So this is the first point. So you are organizing the data and you are bringing all the similar data into one place. Right? So if I give you an example, you can understand it 100%. So you have a huge library. Let's assume that this is our simple example. You have a huge library, right? And in that library, you got, you got thousands of books, right? Now, if I want to search a book with respect to the author, if the table is not clustered or not organized, then unnecessarily I need to search for every book, right? I need to go all the way throughout the library. So my time is wasted. Ultimately, I have to scan more amount of data and I have to pay more money for scanning. So what we will do is I will segregate or I will just sort all the books written by one author into one rack so that I can search the book very fast and very easily. And this is what clustering is all about. Right now, one important question. So even partition does the same thing and clustering does the same thing, right? It means both help us to reduce the data scanning, right? Then the question becomes like which is best, when to go for what? So the question is when to go for clustering and when to go for partitioning, right? So this is for interview question, guys. If you are preparing for interview or attending the interview, always keep this in mind that in partition we divide the table and in clustering we organize the data, and the best fit would be first partition and then cluster. So this is the best fit which will give you more of the efficiency, and this will definitely boost your query performance as well as what the costing perspective, right? So let's see in the video, and in this video I am not demonstrated anything about partitioning. This is just to give you a feel, like, because in interview they may ask such kind of questions, right? So this video is all about clustering, guys. So without wasting any time, let's move on to the video. We can have a simple table here. Okay, let me draw a simple table. Okay, it's like this, and my table name is, say, sales table. Okay, sales table in India. Okay, sales India, or you can say something like that. Okay, now you can put the clustering, okay, for maximum on 4 columns. Okay, you can cluster the table maximum on 4 columns, but in partitioning maximum 1 column. You cannot have 2 column for partitioning. Okay, so now see, just as of now, just park this beside 4 columns or 3 columns and all. Just understand how this is going to work. Okay, so here we have a table, and in table definitely we just assume that we have country, we have state, okay, and we have, say, we have district, and we have town. Okay, makes sense. Now assume that there are 1 lakh records. Okay, 1 lakh records in this sales table, and what I want to do is I want to query based on where, say, state equal to, say, Karnataka. Okay, I want to query something by putting the condition, say, where state equal to Karnataka. Now what happens, okay, if the query will go and scan almost all the rows, because it doesn't know where exactly the Karnataka element present. It has to, it will not take risk. It will say, boss, I don't know, the Karnataka could be present in last row also. I will scan the entire column because I don't want to miss anything. Okay, even though the Karnataka is only present here in the, say 10,000th row, but it will scan the entire row because it doesn't know. Okay, it doesn't know that. It will think it's my duty to scan the entire row and I will give the result based on your query. Okay, makes sense. This is without clustering. Now with clustering the data, what you are doing, you are grouping the states together. You are just creating some clusters based on the dates. You are creating the cluster, sorry, I am absolutely sorry, you are creating the cluster based on this column. What is this column? This is state column. It means that whenever I find where state equal to Karnataka, the query will directly go to this particular cluster. Okay, so this particular cluster, and it will say, okay, I found your result and this is what your data is, all the sales record where state equal to Karnataka. Now if I write say state equal to say Tamil Nadu. Okay, if I write state equal to Tamil Nadu, already I have formed the cluster based on the state. It means I am grouping the data based on states. That's it, as simple as that. I am grouping the data based on the based on the states. Next time where the condition is Tamil Nadu, the BigQuery will directly go to the cluster where I have grouped it based on the state. So it will pick all the details of the state where state equal to this. See how this got simplified. Okay, so this is the concept of grouping. Clustering is nothing but organizing or grouping your data so that BigQuery can easily find your whatever you are asking for it instead of scanning the entire table. Ultimately, partitioning and clustering, they are just make sure that the query should take minimum time to give the result and it should scan as minimal as possible to give the results. Okay, so that's all about clustering as well as partitioning. Okay, so basically there are three types of clustering. What happens is, first you partition the table and then create a cluster. That's the most optimized way. We will do it hands on because if I go on telling here, that will not be as efficient. We will do these concept in hands on because they are quite complex to tell right now. Okay, there are three types of clustering. One is, first partition the table with respect to date, for example, and then cluster with respect to some other column. Next, only cluster the table without partition. Next thing is neither partition nor cluster. It is just your regular tables where you are going to pay more surcharges because there is no partition and there is no cluster. Okay, so that's all about partitioning and cluster. Now we'll understand how exactly clustering works so that you can see a real demo and you'll get the 100% picture of how clustering is really going to help for query or the BigQuery performance optimization. Now I have to demonstrate this. I have created two tables. One is retail, so you can call it as a non-clustered or a normal table, right? So if I look at the preview, you can see there are almost more than lakhs of records here, right? And then I have one more table which I have clustered on the retail itself. This is retail, that is normal, and this is clustered one, right? Now if you see the details of cluster table, they have mentioned that this is clustered by product ID column of the retail table. No need to go in depth right now, right? So here, like I said, if you cluster a table, if you do partition of the table, the schema remains the same, but only change is the rearrangement of rows and the data inside a table, right? So now I will just demo you by two queries. Let me click on query, right? And then let me close this off. Let me open one more query editor and let me just collapse this as well. All right, so I have created a query. This is for normal table. Okay, so let me copy this and let me paste this here. Let me just maximize this so that you can see. Now select product ID from retail. So this is the regular table. This is not clustered, right? This is just a regular table which we have seen. Okay, so let me just have it so that uh, cancel. Okay, so let me go to BigQuery here so that you can easily see the tables especially. Is it opening? Fine. Now select product ID from your non-clustered table and you see that this query is processing 381 point almost 380 381 MB when run. Can you imagine? It will process 380 MB when run. It means if this query will process the more number of information or more number of bytes, then we have to pay more. That's the rule, hardcore rule, right? There is no change in that. Now let me go here and let me just take the same query, but here I will be referring to the cluster table, guys. See, this is cluster table, and now if you see how many queries is processing, just 7.5 MB. Can you imagine, like uh, how much amount of data can you save, and indirectly how much amount of money you're going to save? This is how the working principle of clustering of a table, guys, right? This become absolutely clear. See, same query, if the table is clustered, it is processing just nearly 8 MB of data. If the table is not clustered, this is normal table, then the same query with the same product ID, it will process around 382 MB of data. So it's almost, you know, like 7 10 almost 400. I mean, it's massive, right? So that's the reason, this is why the query works. And moreover, this table is of nearly 9.5 GB, but if we are dealing with terabytes of data or petabytes of data, right, then just imagine like how the clustering helps us to reduce the to reduce the cost up to a huge extent. Make sense? So this is how the clustering works, and that's all in this video, guys. So I hope this is, you will get 100% I mean understanding now why clustering and how it is really helpful. Thanks for watching and see you in the next video very soon. Have a good day, guys. Bye bye.